Right, so let's take a look at number 1 and see if you can answer the question, is this function growth or decay? Then I'm giving you the parent function. Talk to me about how this function's graph is different than the parent, the domain, the range, and the equation of the horizontal asymptote. Okay, so here's number 1. The first thing we want to do is understand that 0.25 is the same thing as 1/4. And that is a number between 0 and 1, so that's going to represent decay. Now, remember though, you before you can just say that it's decay, you have to see how many reflections there are. So since there are 2 reflections, it is decay. And then you can justify that. It says there are 2 reflections and B is in between 0 and 1. All right, so then it says, I'm giving you the parent. How is this function's graph different than the parent? So now you're basically explaining all the transformations. So it's reflecting over the x and the y axis. And remember, to find the value of how you're going left or right, you need to figure out what the x value is. What are you going to do to x to take it back to 0? So you just set it equal to 0, solve for x. That's positive 2, which means we're going to go to the right 2. And then, of course, that positive 3 at the end says shifting up 3. Domain of all exponentials are all real numbers and their range. So now we've got to figure out, we know that the range is going to have something to do with that horizontal asymptote, but is the graph above or below? And there's something specific that tells you whether or not the graph is going to be above or below. See if you can answer that question. All right. So this guy right here, the reflection over the x-axis, is going to tell you whether or not you are above or below. If it's a reflection across the axis, it's going to be below, which means all of your y values are going to be negative up into the horizontal asymptote. And there's the equation. All right, number 2, go ahead and answer all those questions. All right, let's take a look as if it's decay or not. So naturally, the 1/2 would indicate decay, but there's 1 reflection, so that means it's going to end up being growth. All right, and the justification is there's 1 reflection and the B is between 0 and 1. All right, so there's the parent. Let's see if you can, if you were correct when you identified all of those changes. So we have the reflection over the x-axis, which is this negative right here. We've got vertically stretched by a factor of 2. That's my A value. We've got shifting left 3, and then we've got down 1. Domain, always all real numbers. Let's see, we've got our horizontal asymptote. So the range is either going to be, your graph is actually going to either be above or below that horizontal asymptote. This negative tells you that it's going to be below, so it's negative infinity to negative 1. And the equation is y equals negative 1. Number 3, go ahead and answer all those questions. All right, let's take a look at 3. 3 says we've got a number bigger than 1, but we have 1 reflection, so we are back to decay. And there's our justification. There's our parent. Let's talk about how the 2 affects that. The 2 is, well, I guess we're going to start with the y-axis reflection with that negative right here. Vertically stretched by a factor of 2. Remember, solve for x to determine the shifting left or right. So we're going to go right 2, and then we're going to go up 3. Again, the domain is going to always be all real numbers for exponential. Since there is a positive A value, then that means you're going to be above the horizontal asymptote. So that means you're going to start at the horizontal asymptote and go to infinity, and the equation is y equals 3. All right, so now let's take a look at when we're considering f of x and p of x. It says, number 4, one of the functions is a growth and one is decay. Which is which, and how do you know based on the equations? So go ahead and answer that. All right. So what we're going to do, I would like to kind of talk to you real quick before we go and answer that. If you have y equals ab to the power of x, and we've got b is a number greater than 1, then you know that you have a growth. Okay, so let's just say, let me go and do this. We know that growth is going to be increasing. Okay, so let me just talk to you about what those reflections are. So with no reflections, not only are we increasing, but our rate is also increasing. So it's the function is increasing and the rate is also increasing. If we do 2 reflections, we are still with growth. Okay, so we're still increasing, but the second reflection changes the rate. Okay, so the second reflection changes the rate of the increase. So let's see if you could figure this one out. If I have 3 1/2 to the x, this is going to be decay, right? So it's going to be decreasing at a slow pace. So it's decrease, decrease. But if I have 2 reflections, now I have 2, that means it's still decrease because it's still decay, but the rate is going to increase. So that means the function is decreasing at a really fast rate. So that's what that graph is going to look like. All right. So let's take a look. All right. F of x is growth. Let's think, because b is greater than 1 and there are 2 reflections. The x-axis reflection is indicated by the a is less than 0. The y-axis reflection is indicated by the negative coefficient of x. So this should be p of x. P of x is decay because b is between 0 and 1, and there is no reflections. All right, so let's take a look at 5. What is the range of f of x? And explain how you know based on the equation. Okay, so what's going to help you with the range is not only the horizontal asymptote, but the a value, whether or not your function is above or below the asymptote. So y equals 2 is the horizontal asymptote. Since a is negative, the graph is below, therefore the range is going to be negative infinity to 2. All right, so here we've got the point that corresponds to negative 2, 4, and it's a point on the graph of y equals 0.5x, so it's like the parent. What's the corresponding point on the graph of p of x? So we're here, and explain your reasoning. Okay, so remember that we have the point x, y, and it's negative 2, 4, that's the parent. So what we have to do is identify the shifts. So we're going to talk about our explanation right here. The graph of p of x is the graph of the parent shifted to the right 2 units. So that just means the new ordered pair follows this rule, which means negative 2 plus 2 is going to be 0, and the y stays the same. So we've got 0, 4. Number 7. It says, for what values is f of x equal to p of x? Round your answers to the nearest thousandth and explain how you determine the values. Well, if we have these 2 functions right here, we got to look at the b values and see if we can do them algebraically. Remember that to do them algebraically, you have to have the same base. And I cannot do that algebraically right now because you can't rewrite them with the same base. One is 3 over 2 and one is 1/2. So therefore, you're going to have to use Desmos, right? Remember how I showed you how to do that? So please go into Desmos And if you haven't been able to answer this question with to three decimal places, please do that now. Okay. So when you do Desmos, you get the graphs at that intersection point at this point right here. And then this is going to be your answer. Please make sure that you are able to follow that and address that question if you have at the end. All right, here we go. 8. Explain what changes would be made to the graph to obtain g of x. In other words, all you're doing is trying to take it back to the parent. So what are you needing to do? All right, so let's talk about each of these points right here. We've got a reflect over the y-axis. We need to be able to solve for x. So when we do that, we end up getting -2, which means we're going to go left 2. And then we are also going to go down 2. Number 9, what is the coordinate rule that would transform the points? So I just need you to take this information and give me the rule. So the ones that are going to affect the x are going to be the reflection over the y and also the shifting. And then the ones that affect, this is affecting the x, and then this affects the y. So that's what you will have for 9. Number 10, now I want you to apply the rules that you used on 9 to come up with the new ordered pairs. So please answer that question. Okay. These are the points that you would have, again, plugging everything into the new rules and getting these ordered pairs. 11, what changes would be made to the graph to obtain the parent function? Same thing. Identify all of those changes. We've got one reflection. It's an x-axis reflection. We're going to go 3 units to the right and down 2. All right, so now come up with the transformational rule. Okay, so this tells us are going to the right 3. This is our x-axis reflection, and then we're going to go down 2. Using that rule, come up with the new ordered pairs. Okay, double check. All you're doing is taking each of these x values and applying the rule, taking the y values and applying the rule. All right, and then we are supposed to graph. So let's take a look at the graph for g of x. And let's take a look at the graph of f of x.